It's really kind of wild how fast AI is changing everything, isn't it? I mean, trying to keep up with all the new developments feels like a job in itself these days.
Yeah, for sure.
You sent over that article about NVIDIA's announcements at GTC, and man, it really makes you realize just how much things are accelerating.
It's definitely a turning point, that's for sure. You hit it on the head. I think what's really interesting about this NVIDIA roadmap is it's not just like, here's our next product. It's like they're laying out the future of like the whole AI landscape?
Exactly. And that's exactly why we're doing this deep dive today. We're going to dig into Huawei's announcements, Blackwell Ultra, Rubin, even those hints about Feynman, what they really mean.
Right. We want to cut through all the techie stuff and figure out, okay, what are the big implications here, especially for you listening, right? Like, what does this mean for what AI can actually do? And what role does the memory industry play in all this? Yeah, absolutely. I think that's the right way to look at it. These aren't just like small upgrades. This is a huge leap forward in what AI can do and the infrastructure that makes it all possible.
For sure. I mean, some of the numbers Jensen Huang was throwing around were just like mind-blowing, right? He was talking about Blackwell having something like 68 times the AI performance of the Hopper H100.
Yeah.
And then Rubin aiming for 900 times. I mean, it's almost hard to grasp.
It is. It is that kind of increase. It's not just like making things a bit faster. It's opening up possibilities that we couldn't even really consider before. Like whole new areas of research and applications, because suddenly the computing power is there.
It seems like NVIDIA's on this like TikTok cycle, right? Every other year, boom, a big new architecture.
Yeah, roughly every 2 years, they've got a major new architecture coming up.
That must be putting a ton of pressure on everyone else in the industry to keep up.
Oh, absolutely. It's this constant drive to innovate, right? I mean, everybody from the chip designers to the folks making the advanced memory, even the people designing the data centers themselves.
Yeah. Okay, so let's start with Blackwell Ultra, which is supposed to be coming out later this year. Now, this isn't just like a small update to the original Blackwell, is it?
No, not at all. I mean, Blackwell was already a big step forward, but Ultra is kind of like refining and pushing that architecture even further. The big thing here is the increase in high bandwidth memory. HBM.
Right. The article mentioned that it'll have 288 gigabytes of HBM3E memory. I think for some of our listeners who aren't, deep in the chip specs, can you explain why that's such a big deal? What does that actually mean?
Sure. Think of HBM like the AI chip's super fast short-term memory, right? The bigger that memory is and the faster you can access it, the more the AI can do at the same time without having to constantly pull data from slower storage. So with Blackwell Ultra going up to 288 gigabytes, it's like giving someone who's already super smart an even bigger, faster scratch pad to work with. They can tackle much more complicated problems all at once.
So basically, more memory means more powerful AI and probably AI services that are faster and more responsive too.
Exactly. Gets rid of a major bottleneck, make sure those powerful processing cores aren't just sitting there waiting for data.
Got it. Okay, so then moving on to Rubin, which we're expecting late 2026. Now, this seems like a much bigger architectural change, right? Especially with NVIDIA making their own CPU now.
Yeah, Rubin's a pretty big leap. And yeah, the integration of their first in-house CPU, which they've named Vera after, Vera Rubin, the astronomer, that's a big deal. But also the memory's getting a big upgrade, too. Rubin will have 288 gigabytes of HBM4 memory, which is even faster, and that gives it an incredible bandwidth of 13 terabytes per second.
13 terabytes per second. It's almost impossible to imagine how fast that really is. And naming the CPU Vera after the scientist who basically proved dark matter exists, it's a cool nod to pushing the boundaries of what we know.
Yeah, I think it's a great tribute for sure. And it really shows how ambitious they are with this. The key thing about Vera is that it's designed specifically to work with their GPUs. Minimize those bottlenecks you get when data is moving between the CPU and the GPU. So you're talking about a whole new level of efficiency for AI.
And the article even had that quote from Jensen Huang saying that the Rubin NVL144 is going to be 3.3 times faster than the Blackwell Ultra NVL72. So another massive jump in power in just a few years.
Yeah, huge jump. And, taking a step back, I think Rubin shows that NVIDIA really wants to be more than just a GPU company. They want to be the go-to for everything AI, like a full platform provider.
Right.
So they're controlling the CPU, the GPU, the software, optimizing the whole thing. And that could give them a real edge over competitors who are still relying on general-purpose CPUs,
So Rubin's not just a faster chip. It's like NVIDIA saying, we're going to own the whole AI computing experience from top to bottom, right?
Yeah, exactly. They're going for that tight integration, trying to squeeze out every bit of performance they can.
Then we have Rubin Ultra coming in 2027. The article called this the opening of the terabyte era. That sounds huge.
Yeah, Rubin Ultra is taking things to a whole new level. We're talking a terabyte that's 1,000 gigabytes of HBM4E memory.
Wow.
And the NVL576 configuration, it'll have 576 GPUs in a single server. They're aiming for a 14 times speed increase over the Blackwell Ultra NVL72.
1 terabyte of HBM4E and 576 GPUs. Like, those are just numbers that are hard to wrap your head around, you know? I mean, Juan actually said 1 TB of HBM4E, right?
He did. And that's important because as AI models keep getting more complex, we're talking about trillion parameter models now.
Wow.
They need a ton of memory to hold all that data, all those parameters. So it's not just about raw speed anymore. It's about having the sheer capacity to handle these massive AI models.
So it's like if you want to play in the big leagues of AI now, you got to have a seriously huge memory bank, right?
Exactly. And then with 576 GPUs in one server, it's a potential revolution in data center computing power. I mean, this is the kind of infrastructure that's going to be needed for those next-gen AI services, the really demanding ones that we can't even imagine yet.
It feels like we're on the verge of something really big with all this, you know? And then we have Feynman, which is slated for 2028. Now, the article didn't have a lot of details on that, which I don't know about you, but I kind of like that, you know? It's like a little bit of mystery.
Oh, yeah, for sure. It's intriguing. What we know so far is that it's going to have a next-gen HBM even faster than HBM4E, and they're aiming for even more bandwidth than Rubin, which is already aiming for 3,600 gigabytes per second. It's pretty crazy.
And they named it Feynman after Richard Feynman, the physicist. That seems like a pretty deliberate choice, right? Maybe a hint that they're focusing on some like fundamental breakthroughs in the technology.
Yeah, I think it's likely. I mean, we don't know the details yet, but associating it with such a, legendary figure in science, it kind of signals that they're committed to really pushing the boundaries. It reinforces this idea that this rapid innovation isn't slowing down anytime soon.
So it's clear, right, that from Blackwell Ultra to Feynman, NVIDIA isn't just thinking about making faster chips. They have this bigger plan for making data centers way more efficient. And the article talked about their Spectrum-X initiative, which uses silicon photonics, right?
Right. As we're putting more and more GPUs in data centers, being able to communicate quickly and efficiently between them becomes super important. It's not just about how fast each chip is anymore. It's about how well they can talk to each other. So Spectrum-X is their answer to that.
Okay.
It's all about getting high-speed, low-latency communication, and they're doing it with silicon photonics.
Silicon photonics. So instead of sending data with electrical signals, they're using light.
Exactly. Basically, you're replacing wires with light, using photons to transmit data that's way faster than traditional electrical connections and uses less energy.
So faster communication between all these crazy powerful GPUs, and it's more energy efficient. That's got to be a huge win for those massive data centers running AI, right?
Oh yeah, huge. Especially as these data centers are using more and more power, Spectrum-X is a big step towards making them more efficient and sustainable. It's not just about performance anymore. It's about doing it in a way that's, good for the environment too.
Makes sense. And it's not just the hardware either, right? They also released this open source software library called Dynamo, which is supposed to help boost AI inference performance.
Yeah, so we've got all this powerful hardware for training AI models, but then there's also the inference stage, which is basically how do we actually use those models in the real world. Dynamo is meant to make that process super efficient. It's open source, kind of like their PUDA platform, but for inference.
So this helps make AI models run faster and more efficiently once they're trained and, actually being used for something.
Yeah, exactly. Dynamo streamlines that whole inference process so end users get faster response times and the data centers can use their resources more efficiently. The article even had an example where they saw a 30 times increase in the number of tokens generated per GPU on a Chindy 200 NVL72 rack using the DeepSeek R1 model.
30 times faster. So Dynamo's not just some little add-on. It's a key part of making NVIDIA's hardware even more powerful and user-friendly for all those AI developers and researchers out there.
Yeah, it strengthens their whole ecosystem, makes it more attractive to build and deploy AI applications on their platform.
Okay, so let's shift gears a bit and talk about the memory industry. The article mentioned some big opportunities, but also some challenges for the domestic memory industry, especially in South Korea.
Yeah, this is important. So with NVIDIA pushing for more and more HBM in their chips, that's a huge opportunity for companies like SKhainicks and Samsung.
Right.
They're already leading the world in HBM technology, and NVIDIA's future products are going to need a ton of it. So it's a perfect match.
The article mentioned the 1 TB of HBM4E in Rubin Ultra as being a big deal for them. And Jensen Huang even said he's looking forward to Samsung being involved with HBM for Blackwell Ultra.
Yeah, he did. That close relationship between NVIDIA and these Korean memory makers, it could really speed up the development and production of next-gen HBM. And for the Korean economy, it's a chance to grow their global market share even more.
But the article also said that this increase in demand is going to lead to more competition in the HBM market. It's not like they're the only ones who see the opportunity here.
Yeah, you're right. More demand means more players coming in. SKhainix is already moving up their timeline for mass-producing HBM4E. They're aiming for 2026 now. And other big players like Micron, they're looking to get into the HBM game too. It's going to be a race to see who has the best technology.
So even with the demands there, it sounds like these Korean companies can't just sit back and relax. They have to keep pushing the limits with their research and make sure they're delivering top-notch HBM.
Absolutely. They got to keep investing in R&D, keep their quality high, make sure they can produce enough to meet the demand. It's a big opportunity, but they got to work hard to stay ahead.
Okay, so to kind of sum up, it seems like this roadmap from NVIDIA isn't just about faster chips. It's about this rapid evolution of the whole AI field, and the data centers that make it all possible are changing too. And with all this innovation from Blackwell Ultra to Feynman, who knows what AI will be capable of in a few years, right? It's pretty exciting.
Yeah, I think that's a great way to put it. And for the Korean memory industry, it's a chance to solidify their position as global leaders. Working with NVIDIA and pushing the boundaries of HBM, that's going to be key for them.
So for you listening, think about what all these advancements in AI and memory could mean for your work, for the industries you're interested in. I mean, with all this computing power, who knows what kind of possibilities will open up? It's definitely something to keep your eye on.